Hello student, in your data mining next topic is dealing with large database. Dealing with large databases. This is your next topic. In earlier we can see the cluster method and cluster types, everything we can see in before classes. In this class we can see in dealing with large database. In most clustering method we can implicit assume that all data we can accessible in the main memory. What are the data we can accessible? Everything will be we can access it in a main memory only we can access. After the size of the database is not considered, but method is we can require the multiple scans of data or disk resident could be quite inefficient for the large problems we can occur in a database. Why? Because we can have so much of data we can have in data mining. It is we can have a large databases we can have, so we can require multiple scans. We can have this, so disk resident could be we can quite inefficient for the large problem. That is your dealing with large database. It means data we can accessible in the main memory. After the size of database it not considerable, but method required in the multiple scans we can make it and check the data. In your dealing with data large database, there are two types. First one is k-means method. K-mean method for large database. K-means method for large databases. Second one is hierarchical method for large databases. This was two types of dealing with large database. It means we can inefficient for the large problem we can have in data mining. So we can find out the how data we can used and we can used in a data mining. So we can find out that method. These two methods we can use: k-means method for large database and hierarchical method for large database. In your k-mean method for large database, why we can use mean what are the data we can, what are the too large to fit in the main memory. This modified method we can based on the assumption of centroid, or we can starting the is means we can specify the distributed around the data we can have in a large database. It is we can assume that we can start, we have to use the responsible of actual cluster. A cluster means we can grouping of data or more data we can use in a large database. This object belongs to the following three groups. We can make it in a k-mean method. First I will take a three following steps I will return here. I will tell you what are the three steps we can follow. The k-means is those that are certain belong to the cluster. Those that are certain to belong to a cluster. Second one is those that are sufficiently close each other to be the replaced by the summary. Those that are sufficiently close to each other to be replaced by their summary. This is our second following steps, summary. And the last one is the remaining objects that are too difficult to assign either to the two groups or above groups. The remaining objects. These object together or compression set together are called compression set. These two k-means large database. It will be follow the three groups or three set of group we can have in a k-means method for large databases. First one is those that are a certain belongs to the cluster. The object together is called as, we can call it as a discard. This one we can call it as a discard set. This some information about this object we can save we can use the n number of object we can used in this one. The some vector of sequence, all attributes, value of n objects we can use these certain belongs to the cluster. In second one, those are sufficiently close to each other to be replaced by their summary. We can use the object. Here we can use the object. However, sufficiently for always from the each cluster we can centered. They cannot be 8 be put in the discard. We can't we can erase this one we can discard the object together we can call it as a compression means we can compress the video or compression the set or data. This one is second one. This one is we can doing a discard. This second one we can make it in a compression. And the last one we can use the retained set. Last one we can call as a retained set. The remaining objects that are too difficult to assign the either of the two groups, the above this object we can call the retained set. Store the individual object we cannot be replaced by the summary. We can't change it here. We can make it only retained set we can use. Here we can discard the value. We can compression of value. Here we can retain set of data we can use in a k-means method of large database. In your next large database is hierarchical method for large database. Next one is hierarchical method for large database. Hierarchical method for large database. What are the hierarchical large database concept we can use in a fraction of value we can use here in here. It means we can dealing with large database we call difficult to using the hierarchical method. It means we can use the n into n distance matrix. We can use this one, n into n distance matrix we can compute it in the n object. N is a large number of, we can have the matrix format. In this hierarchical method we can use the 5 steps, following steps, or we can use. First one is split the large database into the function of size m. First we can split the large data set into fractions of size m. Fractions of size m. First we can split the value, what are the data set we can have, that one we can split into function of size m. Second one, the hierarchical cluster technique being used to apply to each function. This method we can obtain from the all function b, we can use in a C method. It means this hierarchical clustering technique being used is applied to each fraction. It will be applied to each fraction. We can use the cluster technique being used. Anyway, the next one, third one is, for each of the C cluster, compute the mean of attribute value of the object in it. Let means mi vector b we can consider of m of I means I is equal to 1 up to the C. The cluster means we can call it as meta observation. The meta observation now become the data value that are represented in the fractions. What is the third following steps we can have? We can consider in the cluster, we can call it as C. C is the clusters is compute mean attribute. We can compute the mean of the attribute values of the object in it. We can consider as the vector, be a mi. It means I is equal to 1 up to C. The cluster means all meta observation. It means this one is the meta observation. We can call it as a meta observation. That one is this process we can call it as a meta observation. Next step is, if the C meta observation is too large, greater than, it means we have a large data, too large data we can use, or greater than m. These steps one, otherwise apply the same hierarchical cluster technique, other the meta observation obtained by the step 3. Step 3 means which one we can use? We can use the mean vector of mi comma I is equal to 1 up to the C. That one will be, we can say it in a fourth one. When is we can use that one? The meta observation we can applied. It means step 1. It means greater than value we can have. Then that type we can use the step 3. We can follow the step 3. large data we can occur means we can use the step 3 we can use. Last one is we can allocate each object of the original data set to the cluster with the nearest mean obtained in the step 4. With allocate, what are the data we can allocated each object, the original data we can with the nearest mean value we can obtained in the step 4. We can see it in a four step we can observe. We can each object of the original data set to the cluster with the nearest mean obtained in step 4. This cast of algorithm we can linear terms of size of data set, we can accuracy of result, we can related to the accuracy of clustering algorithm we can use. This effectiveness of approach has not yet been fully investigated, or we can check it in a one by one step. We can check the hierarchical method or large data concept of the fraction of value also we can find it clearly in your large databases, dealing with large databases. Thank you.